Today I learned intermediate stream operation. In my previous video, I talk about basic stream operations. So I will work with some example code and explain. First of all, it will work on the person object. I in my previous video also mentioned this one. This is the immutable um, person. It means the data once is a construct once object is created with constructor, no modification is allowed. uh, so here is the code. So at first we create the person's object like this. So simple array as list, and then you create the person object. Okay, now I'm doing the intermediate operation. As mentioned, I did already the basic operation in my last video. So this is the intermediate operation. So it passing the person array. So here like this is the sort by age persons array receiving array person as array, and then do dot string. It convert to string. So array is converting to string, the first step. Second step is sorted. Sorted is higher order function. It takes another function. Any function which takes another function is a higher order function. So it's sorted. You see here, sorted is taking comparator. Comparator is another function. So it's a higher order function. So how the comparator is working? Comparator take comparing integer, and then person get age. It is a method reference, and comparing integer, of course, is static. So this static was returned the comparator. So we sorted actually need a comparator. So comparing integer is returning a comparator this comparator object. So basically is this call is returning a comparating object, which is actually like like this is the comparator interface. That comparator has a method reference. If you say comparator, like so if I say we can create the similar thing, we can create if I like here comparator, because sorted takes comparator as argument, so it returns the comparator object. So I have to create a comparator object. Say there is another way of creating the same comparator. That's what I'm going to say here. Here comparator takes what the comparator takes. Comparator takes a type. Okay, so what type we are talking about? We are talking about person. Okay, so person type, person person, and then see this is the comparator, maybe this comparator object. Okay, and then we have to give it, we have two comparator. We have to give the implementation of the abstract method. See here, abstract, what is the abstract method? If you go here, you will see the abstract method is this one, compare. Okay, abstract method, by looking at it, I see that compare. So right now I'm doing the code inside what the code should be like in other words, I'm implementing the compare method. Okay, so this compare method is taking two objects here, one o1 o2. Okay, then it means here I have to take two object o1 o1 o2, because that's what I am going to implement. And this is the function, and this is the argument, and the function definition is it takes two argument and return this one. So how is returning work? Let's go to the comparator again. It returns here how the okay, it returns a negative integer 0 or positive integer. Okay, as the first argument is less than or equal to or greater than the second. So we can do one thing here. So here we can see O1 get age minus O2 get age. That will do. Okay, this is because this fulfill the requirement. It says that it should return it's here, yeah, it returns the comparator should return a negative 0, a negative integer 0 or a positive integer as the first argument less than, equal to or greater than the second. So if I do this one, that will do negative integer negative integer 0 or positive integer. If first one is less than second one, or first one is equal to second one, or first one is greater than second one. Like if you do this, then it will work like this. So same thing you can do like if else, you can do it like this, but it's a simpler, easier code. Okay, now we also create the comparator. So since a comparator, I don't have to do like this. If you do this, also do the same thing. See, this I created a comparator. I am using this comparator. It should work. Let's run the code. Person sorted by age. What is the person sorted by age? Person sorted by age. Yes, it is going increasing order. But if you want decreasing order, we can do like this. Sorry, that will do the decreasing order. See, this is decreasing order. Okay, so this is one way of doing it, and another way is another way of like this one. So this one I have to remember comparing integer thing, but to me I understand this better. I don't have to remember this thing, comparator, then comparing integer. You have to remember, otherwise you have to find it through API, or this is simpler in my view and to remembering. Okay, so this is one. Another one is, we'll do this one again, sorted, the same thing, same idea, comparator comparing age get age, but here I'm going to limit maximum 3. So I think it's okay. It doesn't, so give me the 3, maximum 3, limit 3. Okay, same, there's nothing to explain. So it will produce 3. Okay, already I think is, yeah, top 3 youngest person, see, is 3. Now another one is unique hobbies, which is, yeah, I think this one is more need to explain. Unique hobbies means, see here, unique hobby here, result is unique hobby: reading, hiking, cycling, gaming. So if I look at my code, original code, see here, hiking, gaming, reading, hiking, cycling, gaming, see that things sometimes are duplicating, so with a distinct, like SQL, so we can do the distinct. So instead of 2, it will show up 1. And look at the structure. See here, each person has a list. See, one to many. Okay, so for generally map work is 1 to 1. See, Alice and age, Bob and age, like 1 to 1. But if you have one to many, like Alice has many, reading, hiking, Bob has many here, cycling, gaming. In this case, we need a flat map. That means we can you can be a flat bank means you create the first it does the mapping and then you flatting the map. So map first, then flatting, and then distinct. Flatting means you reading and hiking not inside the Alice, not inside the persons. The first one, it will be in it will not be nested. It's like, okay. So the way we'll do it here, flat map is I mentioned this is the here. So this is the flat map, okay. So flat, if I had to, if the data was like legs, then we could have like this. See here, if you are normal map, get, say here, get name, maybe get name or get age. Get age will do map. Sorry, MFT map. Okay, this is the string, that's why it's giving problem. Maybe if I do it in integer, this should work. Yes, see this map, this is map because it's a one-to-one relation, but one-to-many, because of one-to-many relations, which is this array one-to-many, so we need a flat map. So it does map and then flatten. Now how that works, let's do it again. Let's go back. Look, let's see the definition. So person to the stream return a stream, as I mentioned before. So now flat map, now what it takes, flat map takes a functions, okay. I mentioned that what is called wildcard super always a consume. It doesn't return anything, it consume data what I send, and this always wildcard extend always return, okay. And so this is the definition. This extend, this thing, this wildcard extend stream is the definition for return. R is the return value. See, here's the definition. It doesn't look, it looks to me it is argument at the first notice. We think that okay, it takes two argument. It is not like this. This function takes two argument. It looks to me, but in fact it's not like that. Actually this is a function, it takes a single argument, but this is actually a definition. What is the R? What is the T? T means it is a consuming the type, consuming dot super T, whatever the T is, and R means returning, because it's extend here. So that's why this one is returning. See here, there is returning type is R. So it is returning. It is not that function is taking two argument. Function is taking one argument and returning another argument. Okay, and that is the mapper function. That's called mapper function. Okay. Now going back. Again, another interesting thing. See here, person. We know the person is a argument, and then passing it to that person in the argument in the function, and the body of the function body of the function is like this. The first thing is person dot get hobbies, return a list. Agree or not? Yes. Person dot get hobby is a list. Once I've got the list, if I do dot stream, then it become another stream. Okay. So why I need a stream? Because flat map expect stream. Because this flat map in fact expect a stream. See here, map a non-inferring stateless function to apply to each element which produce a stream of a new value. now input I need to say input value, this param, return param a non function to apply to each element which produce a stream of a new value, return the new stream, but it also accepts the flat map function. The flat map operation has the effect of applying a one-to-many transformation to the element of the stream. See here, one-to-many transformation to the element of the stream, and then flattening the result element into a new stream. So one-to-many transformation to the elements of the stream. So that's why I have to send to the stream, send as a stream. It works on the stream flat map. See here, it's clearly written. Flat map operation has the effect of applying a one-to-many transformation to the elements of the stream and then flattening the result element to a new stream. Okay. So that's why it expects a stream. So that's why I had to change it to a stream. Okay. If you don't, then it will not work, because this function, this flat map expect a stream. Also, I look at the API. I also see reading the API also it mentioned the stream. Okay, so the stream is done. So this is return the stream. I agree. Okay, with the flat map operation. So and return, and this whole thing is returning another stream. Okay, again a stream. So once the stream is there, and then we can do a distinct, this regular SQL like distinct value, and then collect list. I know the converting the terminal operations. Okay, now I run the code. What happens? See here. See, this is the result. Unique hobbies is the all are reading. Okay, I think it is clear.